Welcome to the Deep Dive, where we take stacks of information, articles, research, notes, and we really try to pull out the most fascinating bits, the insights that maybe get missed. Our whole goal is to give you a shortcut, really, to understanding something better, maybe sparking one of those aha moments that kind of changes how you see everyday things. And today, we're diving deep into something that's so common, so much a part of our daily lives. It feels incredibly simple, but its journey, it's anything but simple. It's complex, fascinating, and almost totally invisible to us. I am talking, yes, about the humble pencil. I mean, think about it for a sec. This little tool, artists, architects, students, engineers use it. We use it for grocery lists. It just sort of...
It appears.
Right. But have you ever actually stopped and wondered where it comes from? What's the real story behind that little stick of wood with the dark tip? So our mission today, we're going to unpack that. We're going to demystify how a pencil is made.
We'll take you on this really unexpected journey, starting way back with a tree in a forest, all the way through processing, material science, right down to that tiny little point. Our main guide for this is a really great source called The Crafting of a Pencil, From Tree to Tip. Get ready, because there are some genuinely surprising facts in here. Hopefully, you'll walk away with a whole new appreciation for the complexity hidden in this simple object. So let's jump in. This should be pretty illuminating.
It really is remarkable, isn't it? When you actually break it down, the number of steps, the sheer precision involved, all the different kinds of science and engineering, just to make something we barely think about. And like you said, it all starts right at the beginning with the foundation, the wood.
When I first looked into this, I kind of had that thought too. It's wood. You just need a tree, right? Simple. But no, turns out that's completely wrong when it comes to pencils. There's a real science behind choosing the wood. It really does set the stage for everything else that happens down the line.
Oh, absolutely. And what's really interesting here is how incredibly specific the requirements are. Our source lays it out clearly. The main choices are usually incense cedar, maybe basswood, or sometimes poplar. And these aren't just picked at random, based on what's cheap or available. Each one has these very specific qualities, these finely tuned properties that are absolutely essential for making a good pencil.
Okay, so if I'm out in the woods, hypothetically looking for the perfect pencil tree, what am I looking for in cedar or basswood? What makes them the heroes here compared to something tougher, like, say, oak or pine?
That's a great question. It gets right to the core, literally, of the pencil's design. So first off, you need softness. Now that sounds maybe a bit weird for something that needs to be sturdy, right?
A little counterintuitive.
But that softness, that consistent grain structure is key for getting a clean, easy sharpening experience. Just imagine trying to sharpen oak would be a nightmare. Splintering, tearing, you'd never get a decent point. The wood needs to shave away really smoothly, predictably around that graphite core, almost like peeling a fruit cleanly.
Okay, I can totally picture the frustration of a splintery mess instead of a sharp point.
Yeah.
That makes total sense from a user perspective. Nobody wants that.
Exactly. But like I hinted, it's not only about being soft. It's this really delicate balance they're going for. It has to be soft enough to sharpen easily, yes, but it also needs enough strength, structural integrity. That strength is vital. It protects the graphite core inside, stops it from snapping if you drop the pencil or just, press down when you're writing. Think of the wood as this perfectly engineered little protective sleeve.
Strong enough to protect, soft enough to sharpen.
You got it. And there's one more crucial thing. These woods machine really cleanly. They don't splinter or fray easily when they're cut, and that's absolutely critical for the next steps. When they cut those precise grooves for the lead, any wood that's inconsistent or prone to cracking just wouldn't cut it literally. You'd end up with wonky cores or pencils that just fall apart. #tag sustainable sourcing and the initial journey of the log.
It's actually quite reassuring to read that even for something produced in such huge numbers like pencils, our source highlights this clear effort towards being responsible with resources. These trees aren't just, clear-felled randomly. They come from sustainably managed forests. That's built in right from the start. It's not just about making stuff, it's about trying to do it the right way.
That focus on sustainable forestry is definitely a big deal in modern manufacturing, even for everyday items like pencils. It's about thinking long-term, about the environment and making sure those resources are there down the road. So once these carefully chosen logs are harvested, they start their first journey, usually on these big logging trucks heading out of the forest to the lumber mills. That's where the real transformation begins, where the raw tree starts becoming an engineered material for pencils, #C, transforming raw logs into pencil slats.
Okay, so the logs arrive at the mill, sustainably sourced, carefully selected. What's the very first thing they do? Do they just start chopping them into pestle shapes right away?
Not quite that fast. The very first thing is debarking. They need to get that rough outer bark off. It's no good for making pencils. It's usually done mechanically, leaving the clean wood underneath. Then comes the precision cutting. Those debarked logs are sawn very, very precisely into thin, flat boards. These are called pencil slats.
Flats. Okay.
Yeah, and these aren't just rough planks. They're specifically engineered, cut to exact dimensions needed for the next stages. We're talking big industrial saws, sometimes even laser guided, making incredibly accurate, consistent cuts over and over again.
And these slats, are they all the same size? Can you give us a sense of what they look like? Like dimensions?
Oh yeah, uniformity is key here, non-negotiable for mass production. The source mentions typical dimensions about 7 inches long, maybe 2.5 inches wide, and pretty thin, only about 1/4 of an inch thick.
Okay, so like a thin, flat rectangle of wood.
Exactly. Picture that. And that precise size is crucial because everything later on, all the automated machinery that assembles the pencils, relies on those dimensions being identical, slat after slat. Even a tiny difference could jam up the works or lead to faulty pencils. ###############################################################################################################################################################################################################################################################################################################################################################################################
slats, you'd think, okay, ready for the next step.
Yeah.
But it sounds like there's still more prep work, almost like pampering the wood before it even gets near the graphite.
Oh, absolutely. And it's fascinating how much happens to the wood before it looks anything like a pencil part. This prep work, these stages, they're all about preventing problems later, ensuring that final quality and making sure the pencil lasts. So the first big step here is kiln drying. And this isn't just leaving them out in the air, it's a very controlled process. They go into these huge industrial kilns with carefully managed heat and airflow to get the excess moisture out of the wood fibers.
Kiln drying.
Yeah.
Okay. And why is that so vital? I mean, what happens if they skip that or just let it air dry? What's the big deal about moisture?
Skipping it would be disastrous, really. Removing that moisture properly is what stops the wood from warping or twisting or even cracking later on once the pencil is made. Imagine writing with a pencil where the wood casing starts to bend or split just because the humidity changes. It would feel awful, be impossible to sharpen right, and the graphite inside could even break.
Right. You don't want your pencil turning into a pretzel.
Exactly. Kiln drying gives it that long-term stability. But wait, there's more. Even after drying, they get another treatment. They're conditioned, usually with specific moisturizers and sealants.
Moisturizers. For wood, it really does sound like a spa treatment. What's that for?
It's a good analogy. This step helps stabilize the wood even more. The sealants kind of lock in that ideal moisture level, stopping it from soaking up too much humidity later or drying out and getting brittle. And the moisturizers actually make the wood easier to work with in the next steps. They sort of lubricate the fibers, making it less likely to splinter or tear when those grooves are cut. So yeah, it improves machinability and long-term durability.
Okay, so now we have these perfectly sized, super dried, conditioned, pampered wood slats. Are they all good to go now? Or is there like a final exam before they move on to actually becoming pencils?
Definitely a final exam. Before they hit the main production line, every single one of those slats goes through a really rigorous inspection. This isn't just a quick look over, it's serious quality control, often using automated scanners plus human eyes.
And what are they looking for? What kind of flaws would get a slat rejected at this point?
They're hunting for anything that could mess up the final pencil. Things like knots in the wood, those can cause big problems during sharpening, make weak spots. They look for tiny cracks, maybe from the drying process, even with all the care taken. Discoloration can also be a flag. Sometimes it indicates density issues, or maybe just looks bad, which matters for brand consistency. Basically, only the perfect slats make the cut.
Wow.
Only the ones that meet these really high standards get to move on. It just shows the level of detail they go for, even this early in the process.
Okay, it's honestly mind-blowing how much goes into just the wood part. Mm-hmm. But obviously the real star of the show, the bit that actually writes, is what everyone calls the lead. Which, as I learned, is totally wrong, isn't it? No lead involved.
Not a speck of lead, you're absolutely right. And this is where it gets really interesting, debunking that old myth. People way back when thought graphite was a type of lead ore, hence the name stuck.
Oh.
But nope, modern pencil lead is totally lead-free. It's actually this clever, carefully balanced recipe. 3 main ingredients: purified graphite, superfine clay, and water.
A recipe. So each ingredient has a specific job to do, like baking, but for writing.
Exactly like that. Graphite, which is a form of carbon, is naturally soft and leaves that dark mark. That's its job, making the line you see. But pure graphite, way too soft, it would just crumble instantly.
Right, useless.
Totally. So that's where the clay comes in. Usually it's kaolin clay. This is the magic ingredient that controls how hard the pencil lead is. It binds the graphite particles together and gives the core its strength, and the water. It's the binder, the solvent. It lets the graphite and clay powders mix properly into a smooth, workable paste that they can actually shape. Without water, you just have dust. ###B. The art of mixing and the science of hardness variation.
So it really is like a scientific baking process. The exact amount, how you mix it, it all matters hugely for the final result.
It's definitely a mix of science and art, or maybe engineering. They don't just toss these things in a bowl. They use big industrial mixers, maybe ball mills, to blend everything incredibly thoroughly. The goal is this perfectly smooth, consistent paste, no lumps allowed. Any inconsistency would mean a core that writes patchily or breaks easily. And this mixing stage, this is where the whole science of pencil hardness really comes into play. That ratio, the precise amount of graphite versus clay, that's the secret behind all those letters you see on pencils, the H and B. It directly controls how the pencil feels, how dark it writes, everything.
Yes. The H, the B, the HB. I mean, you see them your whole life, right?
Yeah.
On every pencil.
Yeah.
But I never really knew what they meant beyond hard or soft in a vague way. Can you break that down? This feels like a potential aha moment for a lot of us.
It really is. Because it explains something so common but kind of mysterious, it all boils down to that graphite to clay ratio. Simple as that. So if the mix has more clay compared to graphite, the final core, after it's baked, is harder. Those are your H pencils. H stands for hard. A harder core makes lighter, finer lines. It doesn't wear down as fast, so it's great for technical drawing, drafting, things where you need precision and don't want smudging.
Okay, more clay equals harder, lighter lines. H for hard. Got it.
Right. Now, flip that. If the mix has more graphite and less clay, the pencil core is much softer, and it makes a much darker, richer mark. Those are your B pencils. B usually stands for blackness or boldness. Artists love these, especially for shading or expressive drawing. You can get really dark B pencils, like a 6B or even an 8B, for really intense black.
So I want really dark, smooth, almost velvety lines for sketching. I'd look for a high B number, and for super fine, barely visible lines for planning, a high H number.
Wow.
It's like the recipe is stamped right on the pencil.
That's exactly it. You nailed it. And then right in the middle, you have the most common one, HB. It's a balance. It stands for hard and black. Medium hardness, medium darkness. It's the versatile workhorse, good for general writing, everyday notes, schoolwork. So yeah, that little letter code, it's telling you exactly what's inside and how it's designed to perform. Material science in your hand.
That's genuinely cool. Okay, so they've mixed this perfect paste, got the graphite clay ratio just right for an HB or 2B or whatever. How do they actually turn that paste into the long, skinny rod shape we recognize as the core?
Right, good question. That happens through a process called extrusion. They take that thick paste thing of like really dense dough and they load it into this big machine, an extrusion press. This machine uses incredibly high pressure to force the paste through a special metal plate called a die. This die has tiny, perfectly round holes in it.
Oh, so it's like pushing Play-Doh through one of those shape machines, or making spaghetti.
Exactly like making spaghetti. That's a perfect analogy. You force the dough through the shaped holes and out come these long, continuous, thin strands.
Graphite spaghetti. I love it.
Pretty much. They emerge as these long, uniform rods. But at this point, they're still quite soft, kind of like dried clay. They get cut to the right length and laid out, ready for the next really crucial step, getting hard enough to actually write with.
Okay, so these graphite noodles are still soft. How do they make them tough enough to handle writing and sharpening and not just crumble? This sounds critical.
Oh, it's absolutely critical. Probably the most critical step for the core itself. Because you're right, without this stage, the pencil lead would just be useless dust. This raises the question, how do they do it? It's a two-step heat treatment. First, those soft rods are dried carefully, maybe in ovens at a lower heat, just to get most of the water out slowly. This prepares them for the intense heat coming next, stops them from cracking.
Okay, gentle drying first. Then what? The really hot part.
Then comes the furnace. The dried cores go into special kilns, like pottery kilns, and they get baked. Really baked. We're talking temperatures around 1,000 degrees Celsius. That's over 1,800 Fahrenheit.
Whoa, that's incredibly hot.
It's intense, and they stay in there for hours, maybe even days, depending on the hardness they're aiming for. This extreme heat does something amazing to the clay inside. It vitrifies it.
Vitrifies? Like turns it into glass?
Sort of, yeah. It essentially turns the clay into this hard ceramic-like binder. It fuses all those graphite particles together permanently. That's what makes the core hard, strong, durable, able to withstand writing pressure and sharpening. It's fundamental.
Okay, super hard, super durable cores. Got it. But, sometimes, especially with cheaper pencils, they can feel kind of scratchy on the paper, right? Like they drag a bit. Is there anything they do to make them glide smoothly?
Ah, yes. Another clever finishing touch that makes a huge difference to how it feels to write. After they come out of that super hot kiln and cool down, the hardened graphite rods aren't quite done. They get treated one last time, usually by being dipped in or coated with hot wax or sometimes special oils.
Wax, really?
Yep. Seems like a small thing, but it has a massive impact on the writing experience.
So that really satisfying, smooth feeling you get with a good pencil. That glide isn't just the graphite itself, it's actually this extra waxing step.
That's fascinating. Changes how I think about it completely.
Exactly. The wax acts like a lubricant. When you write, the graphite and clay particles come off onto the paper, and the wax helps them flow more easily. It reduces the friction between the core and the paper surface. Makes writing feel smoother, more effortless, less scratchy. It's important for comfort, especially if you're writing a lot, and also for getting consistent lines in drawing. Just another small step with a big impact on the final quality.
All right, so we've got our perfectly prepped wood slats, dried, conditioned, the whole 9 yards. And we've got our graphite cores mixed, extruded, fired super hot, and waxed for smoothness. Now, how did these two precisely made parts finally meet and become an actual pencil? Hashtag tag, 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 tag A. Grooving the wooden slats.
Okay, this is where the assembly magic starts, and it's all about automation and precision. Those wood slats we talked about earlier, they get fed into another specialized machine. This one has these complex rotating cutters, and its job is to carve a series of perfectly identical grooves or channels down the length of one side of each slat.
So literally cutting little trenches for the graphite to lie in.
Exactly. Each groove is precisely shaped to hold one graphite core snugly, and the precision here has to be spot on. The depth, the width, the spacing between grooves, all identical, because if a groove is even slightly off, the core won't sit right, and you'll get one of those annoying pencils that sharpens all lopsided or the lead breaks constantly. So this grooving is another really critical step. Hashtag tag, 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 B at the pencil sandwich assembly.
Okay, perfectly grooved slats. Ready for the filling. How do they get the lead in there and seal it all up?
This part is kind of elegant in how it works, but it needs incredible accuracy, usually done by robots these days. Those finished graphite rods, fired, waxed, ready to go, are carefully placed into the grooves on one slat. You can picture rows and rows of these cores dropping perfectly into their little wooden beds. Then a second groove slat, identical to the first, is placed precisely on top. It lines up perfectly, sandwiching the cores between the two pieces of wood.
The pencil sandwich. I like that term from the source. So what holds this sandwich together? Glue.
Yep, a very specific strong glue. It's applied between the slats, around the cores. Then the whole sandwich goes into usually a hydraulic press that applies a lot of pressure. This ensures the glue spreads evenly and creates a really tight, strong bond everywhere. Then the glue has to cure, often helped by controlled heat or drying, making the bond permanent. And again, the precision here is just immense. Like the source says, if those two slats are misaligned even by a tiny fraction, the whole pencil is compromised. The core will be off-center, it'll sharpen badly, basically useless.
We've all had that pencil, right? Where the lead is way off to one side after you sharpen it. Now I know why. Bad sandwich alignment.
Exactly. Probably had a rough day during assembly.
So now we have this solid block, this pencil sandwich, with maybe, 9 or 10 cores sealed inside? But it's still just a block of wood. How does it become the individual pencils we use?
Right. That solid block, the sandwich, moves on to yet another cutting machine. This one's job is to slice that block up into individual pencils. It uses super sharp, very precise blades, sometimes tipped with carbide or even diamond, designed to cut cleanly through both the wood and the graphite cores inside without causing chipping or breakage.
And does it just cut them round? Because pencils come in different shapes, don't they? Hexagonals is really common.
Good point. The machine can be set up to cut different profiles. While you do see round pencils and sometimes triangular ones, which some people find comfy, the hexagon shape is definitely the most common.
Is there a reason for that? Or is it just tradition?
Oh, there's a very practical reason. It's not just looks. The hexagonal shape is generally easier for most people to grip securely than a perfectly round pencil. Less likely to slip, maybe less tiring for your hand if you're writing a lot.
Ah, makes sense.
And the other big benefit, it doesn't roll off your desk. A simple thing, but super annoying when your pencil keeps making a break for the floor. So that hexagonal shape, smart, practical design.
Okay, we've got individual pencils, shaped with the core perfectly centered inside, hopefully. They work, technically, but they still look like plain wood. Now comes the part where they get their color and finish, right? Making them look like the pencils we buy.
Exactly. Even after that precise cutting, the surface of the wood might still have tiny rough spots or edges. So before any paint goes on, they get sanded, thoroughly sanded. They go through machines that smooth down all the flat surfaces and edges. This isn't just cosmetic, it's crucial for the paint job. You need a perfectly smooth surface for the paint or lacquer to adhere properly and look good. It ensures that final polished feel. Hashtag B. Multiple layers of lacquer or paint.
And then the color. I always imagine they just like dipped them in paint once. Quick and easy.
Yeah.
But the source says it's way more involved.
Oh, way, way more involved than a quick dip. This is actually one of the more time-consuming parts. Pencils get coated in multiple layers of lacquer or paint. We're talking usually between 4 and 10 coats, sometimes even more for really high-end pencils.
10 coats? Seriously? That seems like a lot of effort for a pencil. Why so many layers?
Well, it serves 2 really important purposes. First, protection. Those layers build up a tough, durable shell over the wood. It protects it from moisture, dirt, oils from your fingers, just general wear and tear. Helps the pencil last longer.
Okay, protection makes sense. What's the second reason?
The second is obviously the appearance. Multiple thin layers create a much smoother, richer, more uniform color and finish than one thick coat would. It gives the pencil that nice gloss or smooth matte feel, makes it look professional and feel good in your hand. It's about quality, both functional and aesthetic. Hashtag C. The iconic yellow and its surprising history.
Speaking of color, you can't talk about pencils without talking about yellow. It's the classic pencil color, right?
Why yellow? Is it just a bright color they picked, or is there more to it?
This is such a great story. A real aha moment about how everyday things get their look. And it absolutely raises that question of how branding and history shape design without us realizing.
Yeah.
That iconic yellow, it wasn't random. It was a very deliberate, very clever marketing move by pencil makers way back in the day.
Marketing for color. Okay, tell me more. This sounds fascinating.
So back in the 19th century, some of the absolute best quality graphite in the world was being sourced from China. It was considered top-tier stuff. Now, in Chinese culture at that time, the color yellow was strongly associated with royalty, with prestige, with the emperor. Think imperial robes, palace tiles. Yellow meant high status, luxury, supreme quality.
I think I see where this is going. Exactly. Western pencil manufacturers who were using this high-quality Chinese graphite wanted to signal that quality to their customers, so they started painting their premium pencils yellow. It was a way to subtly associate their product with that idea of Chinese imperial quality and luxury, leveraging that existing cultural symbolism. And it just stuck.
Wow. So that standard yellow pencil we see everywhere is basically a piece of 19th century marketing genius linked to Chinese history and graphite quality.
Yeah.
That's incredible. I will never look at a yellow pencil the same way again. That's amazing.
Isn't it? A fantastic example of history hiding in plain sight. Hashtag D. Stamping for identity. It really is.
Yeah.
So once all those layers of paint are on and perfectly dry, there's one last step for the finish, the stamping.
Right. This is where they put the brand name, maybe the country it was made in, that important little hardness grade, the pencil's ID badge.
Precisely. They stamp on the brand, the model, and crucially, that hardness grade, the HB, 2B, 4H, etc., that tells you how it will write. This is usually done with hot foil stamping, pressing heated metal foil onto the pencil, or sometimes with ink printing. Needs to be clear and durable so you know what you're buying and using. It's the pencil's final mark of identity.
Okay, for a lot of us, especially thinking about school or just everyday use, a pencil needs an eraser on the end. It feels almost essential. How does that little rubber bit get stuck on so firmly?
Oh, the eraser. That involves another little piece of engineering, the ferrule. That's the small metal ring you see gripping the eraser, usually made of aluminum or brass. Seems like a tiny part, but it's absolutely crucial for holding the eraser in place. It's the anchor.
And how does it get attached to the pencil itself? It feels really secure, not just glued on.
No, not glued. It's crimped on. The pencil end goes into the ferrule, and then a machine applies pressure, physically squeezing or crimping the metal band tightly onto the wood. This creates these little indentations that bite into the wood, making a really strong mechanical grip. That ferrule isn't going anywhere. It's the housing that will hold the eraser. Hashtag B, the eraser integration.
Okay, so the metal ferrule is crimped onto the wood, then the eraser just pops in.
Pretty much. A small cylinder of the eraser material, usually synthetic rubber or vinyl these days, is inserted into the open end of the ferrule. And that same crimping process that holds the ferrule to the wood also usually slightly tightens the top edge of the ferrule, holding the eraser firmly inside. It stops it from twisting or falling out when you use it. Simple but very effective design.
Now, you mentioned this whole eraser part is optional. That caught my ear because, like I said, most pencils I use have erasers. Why make them without?
That's a good point, and it really highlights that pencils are used for different things. While most general-purpose pencils have erasers, you'll often find artist pencils or technical drafting pencils without them. Professional artists or drafters often prefer using separate, specialized erasers, kneaded erasers, vinyl erasers, different shapes and sizes that give them more control or are better suited for specific papers or techniques.
Right, they want their own tools.
Exactly. For them, the built-in eraser might just be extra bulk or not even the right kind of eraser for their work. So omitting it is a deliberate choice for those specific types of pencils, catering to users who prioritize the graphite performance above all else.
We are so close. We've got fully assembled, painted, stamped pencils, maybe with an eraser, maybe not. It's been quite the journey. What are the absolute final steps before they end up in our hands? Hashtag, pre-sharpening or not?
Almost there. One of the last decisions is whether to sharpen them or not. Some manufacturers run their pencils through big automated sharpening machines before they go in the box. This gives you that instant gratification, open the box, grab a pencil, ready to go.
Yeah, I like it when they're pre-sharpened, so why wouldn't they sharpen them?
Well, leaving them unsharpened can protect the points during shipping, less chance of breakage before they even reach the store. It might save a tiny bit on manufacturing costs too. And sometimes, especially for artist pencils, they leave them unsharpened because the user might want to shape the point themselves in a specific way, like a really long, fine point or a flat chisel edge. So it's a choice based on the target user and logistics.
Sharpened or not, are they ready for boxes yet? Or is there one last look over, one final quality control gate?
Absolutely one last check. Before they get packaged, every single finished pencil gets inspected. This is the final chance to catch any flaws that might have slipped through or happened during the last stages. The final exam, you could say.
What are they looking for here? Any common last-minute problems?
They're checking for things like those off-center cores we talked about makes sharpening a nightmare. They look closely at the finish, any chips in the paint, smudges, bad stamping. If they are pre-sharpened, they check for broken tips or splintered wood around the point. They want to make sure only the pencils that meet their quality standards actually make it out the door. That commitment to quality goes right to the very end.
And finally, after passing that last inspection, they're ready to be boxed up and shipped out.
That's it. They typically get put into those familiar cardboard boxes, often a dozen, 12 pencils per box for retail. Then those smaller boxes get packed into larger cartons or cases for shipping to distributors, then onto stores all over the world. And finally, they arrive, ready for us to pick them up and start writing, drawing, creating, putting all that incredible hidden engineering to work. Hashtag tag out TriQuip.
So what does this all mean? I mean, we started this whole deep dive with just a pencil, something so simple, right? But we went on this incredible journey from a specific tree in a managed forest and some special kind of rock, basically. All right. And through all these steps, precise cutting, intense heat, clever chemistry, amazing machines, even some surprising marketing history, we ended up back at that humble pencil. It's really just a testament to human ingenuity, isn't it? The detail that goes into even the most everyday things.
It really is. It makes you stop and just appreciate the sheer amount of thought, science, and history packed into something you probably use without a second glance. Every single part, every step we talked about has a purpose. It's all engineered.
And get this, here's a final little fact to blow your mind. Did you know that the average pencil, just one pencil, can draw a line over 35 miles long? That's about 56 kilometers.
Wow.
Seriously, think about that next time you pick one up. It's not just for jotting notes, it's like a little marathon runner of creativity sitting on your desk.
That's an amazing statistic. Really drives home the efficiency and durability built into it. You know, this whole dive into the pencil. It really makes you wonder, doesn't it, how much incredible complexity and fascinating history is hiding just beneath the surface of other simple things we use every day. This raises that important question: what else are we taking for granted? Maybe start looking a little closer at the objects around you. You might be surprised what you find.